There's something out there, far beyond the edge of our imagination, that shouldn't exist. A colossal cosmic cloud, silent and ancient, floats in the darkness of space, older than the universe itself. How can that be? According to everything we know about time, physics, and the Big Bang, the moment that supposedly created everything, nothing should be older than 13.8 billion years. Yet, this massive cloud of hydrogen and helium seems to defy that law. It doesn't just stretch the rules, it challenges the very timeline of existence. If this cloud truly formed before the Big Bang, then our entire understanding of cosmic history could be wrong. Are we missing something fundamental about how the universe began? Could this cloud be evidence of a universe before our own? Or is it part of some vast cycle of cosmic rebirth? In this video, we'll explore the origins of this mysterious cloud, what scientists believe could explain its impossible age, and how it could connect to radical theories like multiverses, dark matter, or even a time before time itself. The object at the heart of this cosmic riddle isn't a star or a galaxy, or even a black hole. It's a primordial gas cloud, made mostly of hydrogen, drifting quietly in the vast, cold reaches of deep space. Scientists first detected it using the most sensitive radio telescopes on Earth, buried in oceans of cosmic static. It was found in a region more than 13 billion light-years away, meaning we're seeing it as it was just a few 100 million years after the Big Bang. But here's the twist. The spectral signature of the gas, its elemental fingerprint, suggests an age that predates the universe as we know it. That's not just unusual, it's revolutionary. This cloud, known by the technical designation HD1, wasn't initially recognized as extraordinary. Astronomers thought it was just another early structure forming after the Big Bang. But as more data poured in, especially from follow-ups using the ALMA array and the James Webb Space Telescope, anomalies began to emerge. Its redshift, a key measure of cosmic distance and time, was so extreme it pushed the very edge of our observational timeline. If the calculations are correct, HD1 formed before the earliest stars, before galaxies had even coalesced, maybe even before time and space began expanding. What really sent shockwaves through the astrophysics community was the idea that this wasn't a one-off. Similar signals have been detected before, briefly, faintly, and always dismissed as noise or instrument error. But now, the pattern is undeniable. Something ancient is out there, waiting to be understood. To understand what makes this cosmic cloud so puzzling, we need to talk about how the universe actually began, at least according to what we currently believe. The Big Bang wasn't an explosion in space, it was an explosion of space. Around 13.8 billion years ago, everything, time, matter, energy, burst forth from a single point and began expanding outward. In the minutes that followed, the universe was a seething hot soup of particles. Only the simplest elements like hydrogen and helium could form. It took hundreds of millions of years for the first stars to ignite, fusing hydrogen into heavier elements and lighting up the cosmos for the first time. So when we detect a cloud like HD1, made mostly of hydrogen and helium, that in itself isn't strange. But what is strange is how old it appears to be. Based on its redshift, a stretching of light caused by the expansion of the universe, HD1 seems to exist before even the first stars. That's like finding a fossil of a bird in rock layers older than the age of dinosaurs. It shouldn't be there. To confirm its age and composition, scientists used advanced tools like the Atacama Large Millimeter Array, ALMA, and the newly deployed James Webb Space Telescope. These instruments are capable of detecting faint signals from across the universe, essentially acting as time machines that let us peer into the distant past. What they found was staggering. The cloud wasn't just ancient. It lacked the signatures of heavier elements, suggesting it had never been enriched by stellar processes. No nearby stars, no remnants of supernovae, no signs of activity that could have shaped it. It was pure, untouched hydrogen, pristine in a way that even the earliest stars can't match. This raises serious questions. How could it exist in such a pure state, so far back in time, without being part of the chaotic energy following the Big Bang? Could this be leftover material from a universe before ours? Or is our entire cosmic timeline incomplete? Whatever the answer, HD1 is more than just a cloud. It's a message from the beginning, or maybe even before the beginning, of everything. Here's the mind-bending part. Whatever happened to this cloud, whether it's collapsing into a proto-galaxy, forming stars, or doing something we've never seen before, it may have already occurred billions of years ago. HD1 is located over 13.3 billion light-years away. That means the light we're seeing now began its journey across space not long after the universe was born. We're looking into a time so ancient, so remote, that whatever is happening there isn't happening now. It already happened. We're just receiving the cosmic postcard, eons after it was sent. And if HD1 is in the process of collapsing or undergoing some kind of transformation, it might have already become one of the first galaxies or even vanished completely. But from our perspective, it's all unfolding in slow motion. Every new photon we collect adds another piece to this mysterious puzzle, and with each passing year, our telescopes see a tiny bit more, like watching the first sparks of fire before a great cosmic blaze. If something dramatic did happen there, say, a chain reaction of star births or a supermassive black hole igniting, we may eventually witness the light from that moment reach us. Imagine it. A silent flare in the distant dark, perhaps shining with the brightness of a full moon, not just visible, but unforgettable. We may not know when, or even if, that light will arrive, but we're watching, waiting, because when it does, it could rewrite the entire story of how the universe began. Imagine stepping outside one clear night and looking up, only to see a glowing point of light that wasn't there the night before. It doesn't twinkle like a star. It pulses, slowly, with a soft but eerie brilliance. As days pass, it grows brighter, so luminous it becomes visible even during daylight hours. Not just a dot, but a halo of cosmic fire etched into the sky, brighter than Venus, rivaling the full moon. That's what it might look like if something within HD1 suddenly burst into cosmic activity, like the birth of a galaxy or the ignition of a quasar at its core. For weeks or even months, that strange light would dominate our skies. Telescopes across the world would lock onto it. News outlets would call it the discovery of the century. Some might fear it, others would simply watch, awestruck. Because we'd all be witnessing something not seen since the dawn of time, a glimpse into the universe's first heartbeat. To see such a flare from something so ancient is like hearing an echo from a forgotten era, a whisper from a time before time. It would be a reminder of how small we are and how lucky to be alive at the moment when the universe finally gives up one of its deepest secrets. This wouldn't just be a celestial event. It would be history unfolding in the sky, a once-in-a-civilization light show born from the edge of forever. The discovery or explosion of something like HD1 isn't just an astronomical curiosity. It's a scientific gold mine, one that could reshape our understanding of everything from the birth of galaxies to the very origin of time. Events like these are more than bright flashes in the sky. They're cosmic forges, churning out the elements that make up planets, oceans, and even us. When massive stars die or when ancient clouds collapse, they create the heavy elements, gold, platinum, uranium, through processes like supernovae or neutron star collisions. Without these cataclysms, the periodic table as we know it wouldn't exist. So, in a strange and beautiful way, we owe our existence to ancient events like this. Every atom of carbon in your body, every molecule of oxygen you breathe, was formed in a long-dead star or born from a cosmic structure like HD1. It's cosmic recycling on a grand poetic scale. We are, quite literally, made of stardust. Other giant stars like Antares or VY Canis Majoris are massive, luminous, and awe-inspiring. But even they feel local compared to HD1. They're part of our galactic neighborhood. HD1 is from a different era, a different chapter in the universe's story. If it really is older than the Big Bang, it could point to physics we've never even imagined. Maybe hints of a multiverse or remnants of a cosmic cycle that predates everything we know. And that's the deeper meaning here. This isn't just about watching light in the sky. It's about understanding who we are, where we came from, and what might have come before us. Despite how dramatic it all sounds, there's no danger to Earth from an event like this. HD1 is so unimaginably far away, over 13 billion light-years, that even the most powerful explosion it could produce wouldn't come close to harming us. No gamma rays, no shock waves, nothing that could pierce our solar system's protective bubble. What we'd see is light, pure, ancient light that has traveled across time and space just to reach us. In fact, any atmospheric effects would be more beautiful than threatening. If the event were energetic enough, we might experience stronger auroras near the poles, or slight changes in our upper atmosphere's ionization. But these effects would be harmless and fleeting, more like a cosmic light show than a disruption. What's even more fascinating is that we might get an early warning. Neutrino detectors buried deep underground, like Super Kamiokande in Japan, can sense ghost-like particles released from stellar events before the light arrives. That means astronomers around the world could receive a heads-up, giving us precious moments to turn every telescope toward the heavens. No panic, just awe, science, and a front-row seat to the unfolding drama of the cosmos. We're witnessing the final breath of a giant, a farewell millions, maybe billions, of years in the making. The light from HD1 began its journey when the universe was still in its infancy, when the first stars were just flickering to life and galaxies were no more than fragile dreams. Now, that ancient light touches our telescopes, our eyes, and our imagination. It's a message from a time so distant that human language can barely describe it, and yet, here it is, whispering its story across the void. Moments like this remind us how astonishing it is just to be here, to be conscious, to be watching, to be part of a universe that is not only vast but alive with motion, transformation, and mystery. HD1 may be gone, or it may be doing something that will rewrite the history of physics. Either way, it's a humbling signal that we still know so little, and that's the beauty of it. So the next time you look up at the night sky, remember, you're not just seeing stars. You're seeing stories, deaths and births, echoes and beginnings. And somewhere out there, another ancient light is already on its way, crossing the endless dark to meet us. Stay curious. The universe is far from finished. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. We'd love to hear what you think might be hiding in the farthest corners of the universe.